As promised, I wanted to go ahead and talk about a proof that proves that this statement is true. I'm going to go off to the side over here. I've redrawn this diagram, and what I'm going to do in order to prove this, I'm going to go ahead and draw a diameter from D, so going straight across, and we're going to worry first about just this first intercepted arc and this first angle right here. So the intercepted arc, I'm first going to go ahead and just do this as if I have a number. So let's just pretend this is, let's say 80 degrees. Let's say that's 80 degrees. Okay. So if that were 80 degrees, we could actually create a little triangle right here with C, A, and D. And we learned last time that 80 degrees would be the same as the central angle right here of 80 degrees. If that were 80 degrees, then this angle right here should be 100, because you just subtract it from 180. And these two sides right here are going to be equal since they're the radius length, meaning these two angles should be equal. Well, these two angles should make up the remaining 180 degrees. Well, there's 80 degrees left over, so it's going to be half of 80, which is 40 for each one of these to get a 180 degrees. So same idea would play out even if we did oops, didn't want that much erased. Even if we went ahead and made this just a generic x value, okay? So if that were a generic x, same idea will play out. These sides will still be the same. These angles will still be the same. This right here will still be x. And in fact, I said last time this is just 180 minus x, but you should know that these two angles right here should add up to x, okay? So the angle right here and right here should add up to x, meaning since they're the same, they have to both be a half of x, okay? Well, you can do the same thing now that I've kind of shown that right there. You could do the same thing with this inscribed angle right here. Let's say this is y over here. That means this will be 1/2 of y. It's kind of hard to write. So 1/2 of y inside there. And we're talking about this angle in there. Just a little tiny angle though. That means angle D, the measure of angle D, is going to be 1/2 x plus 1/2 y, or 1/2 times x plus y, okay? While the arc right here would be, so from A to B, the measure of arc AB, let's just pretend it's a minor arc, will be x plus y. So notice 1/2 x plus y and x plus y, so the measure of angle D will always be 1/2 of the measure of the arc AB. And that's how it works.